Hello, welcome. Today let's try to solve another lead code problem 668, case smallest number in multiplication table. Yeah, so basically we should know what is a multiplication table. So basically this is 1, 2, 3. For the second one, it is 2, 6, and 2, 4, and 6 for the third one. So this means the index start from 1, not 0. So index is from here, it is 3. 3 times the column 1, it is 3. 3 times column 2, it is 6. 3 times the column 3, it is 9. And yeah, we can put it into a 1D array and sort it. We just need to return the case smallest value. For this example, it is the fifth smallest value, so it is 3. Yeah. Before solving the problem, I'm gonna tell you some method of solving lead code problem. Yeah, actually, all the lead code problem have patterns. If we solved the similar problems, it means next time, yeah, there's a high probability that we can still solve it if we already learned the patterns. Yeah. So for the binary search, there's a lot of patterns, but basically there are like a base case, normally for the easy problem and medium problem, and there are also the guess value case. So for the guess value cases, there are medium problems and hard problems. Yeah, basically for guess value, we just give an array. We just need to guess a value if this value is inside, and so there are like 30 medium of guess value problems. If you solved the like Coco eating bananas, you should know what is a guess value problem for binary search. And there's also hard problems like a split array, largest sum. Yeah, it is also a guess value or divide calculate. Yeah. So this means if you solve some of the patterns for the next time, you would learn from it. Yeah, and for this problem, it is the 668. It is the case smallest number in multiplication table. Yeah, and I've already solved the matrix problems. So this is a matrix pattern. For binary search, I've already solved this matrix, 2D matrix 1 and 2, and I've already solved the case smallest element in a sorted matrix. So this is also a guess value. Even it is a matrix problem, but actually it is also a guess value problem. Yeah, if you learn the lead code like this normally, yeah, you can solve the similar problems very fast. Yeah, now we are going to solve this problem. Because I solved this problem, I think, oh, it is similar. Maybe I just need to change a little bit code and to solve it. Yeah, now let's go back to the question. So basically this is a multiplication, but we don't have a matrix. Let's check the value. So the m at n is a very big number, 3 times 10 to the power of 4. If I use to put these numbers like inside a matrix, I'm gonna solve it similarly, like the case smallest element in a sorted matrix uses this way to solve it. Yeah, it will get time limit exceeded because I cannot use so big memory or so much time. Yeah, because basically the m times n, it would be 9 times 10 to the power of 8. Yeah, I'm not sure if it will be time limit exceeded, but I believe it may be time limit exceeded because the time and memory is so big, yeah, for this problem. So I can imagine, what if I have a matrix? Yeah, but actually it doesn't. But I can just imagine there's a matrix in my mind. I can use this matrix to solve the problem. Now I just need to change a little bit of the this problem, yeah, of the case smallest element in a sorted matrix, yeah, to solve the multiplication problem. Yeah. Now let me change it. So from here, so the smallest value it is 1, because for the multiplication table, the smallest value we already know it is 1. So what is the biggest value? So the biggest value is r times c. Yeah. Let me put a c. Yeah, because here I use the R and C to represent the rows and columns, as you can see it. So this is the row and here is the column. Why I use R and C? Because to make a problem as a template, I need to fix my variables. Otherwise, I'm gonna be very confused and it's really easy to make mistakes. Yeah, as you can see here is m. If I still use m and n, so what if my variable here is still m? So it means that there's a duplicate of m. It may make mistakes. So I should always be consistent with R and C, yeah, with the rows and columns. So here, the biggest value for the R pointer, it should be R times C. and I can give a temporary result as 1. Yeah. Now let me check if I need to change here a little bit or not. So here basically I don't need to change anything. Yeah, because this is the same idea to use a binary search to guess a value. Yeah. If you already know, I've already posted 3 videos about this one, this one, this one, and this one. If you check my video for this one, Kth smallest element in a sorted matrix, now you should know why I use the template like that. Yeah. Yes. So in this video, basically, I just wanted to prove that for solving the lead code problem, we need to use the similar patterns like the machine learning or deep learning. So this is like a neural network. So here, we're gonna first learn from here for here and then find the patterns. And this is for the proper guessing, forward propagation. And now we need to also use backward propagation. So this means we're gonna train it. So maybe we need to find 5 or 10 minutes or half an hour to train each of the problems. Yeah, if we train each of the problems, it means we already recognize the pattern. So for the next time, we can just go forward to the tree structure to find the problem. Yeah, oh, it is similar to this problem, and what I've already solved it. I've already used the this method, guess value method. Now I can still solve it. Yeah, now let me go back. So for here, as I explained, I'm gonna basically prepare this check function, but I don't have a matrix, so I just need to imagine what if I have a matrix and what is the values. Actually, I don't need to take the values inside the matrix. I can just use mathematics to check the value. And the idea is similar. So I just use the similar ideas from the last question. Yeah, just need to check for each columns and go up and then for checking each of the columns. Yeah, to check how many numbers. If this count is more than or equal to k, it means my check is true. Otherwise, it is false. Yeah. Now let me update the values. So for the r and c and count, so the r would be the same because this r is a representation of the index. This r is not, for example, here is 3. It is not 3. It is 2. This r just means the index is 2. Because for here, I just use a simulation. I just need to simulate what happens if all the values is inside a matrix. Yeah. So r and c is the index. It will be r minus 1 and 0, and the count will be 0. And while my index is inside the boundary, this means r is more than or equal to 0 and c is less than capital C. So I'm gonna check the matrix. But currently, I don't have a matrix, but I'm gonna simulate it as a matrix. So how can I simulate it? So I can directly use r plus 1 times c plus 1. Why I use it like this? Because this is the representations of a multiplication table. Yeah, as you can see here. So the mat ij should equal to I times j. Yeah, because my index is starting from 0, so I need to r plus 1 times c plus 1. Yeah, if it is less than or equal to the threshold, it means my count would be plus or equal to r minus 1. If you don't understand that, please check my video for this problem, lead code 378. Yeah, because basically, when you want to learn this pattern, like matrix guess value, basically you need to try 3 or 4 problems to recognize this pattern. Yeah. Now I think I don't need to change anything. Basically, this is all of it. Yeah. Now let me run it to check. There's some wrong because I should not use less of matrix. I should use m and n. Yeah. Yeah, because m and n are the rows and columns. Yeah, as you can see, it passed. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases. Yeah, and we don't need to always check the speed from here, the percent. But basically, for us, we just need to analyze the time complexity. Yeah. Now let's analyze the time complexity. So the time complexity is the same. Let me put it here. So the time complexity is log r minus l and n times r minus l. Yeah. So this r minus l, we need to check the value of r and l. Let me check it. So r times c is a big number. So 1 to this number, it is 10 to the power of 8 times 3 times 3 is 9. Yeah, basically it is 9 times 10 to the power of 8 and times n. So n is 3 times 10 to the power of 4. So it means it is still a very small number. So this means why we can pass for the lead code. Yeah, thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more lead code problems like this. See you next time.